Hello everyone. In this lecture, I will compare between continuous time Fourier transform, discrete time Fourier transform DTFT and discrete Fourier transform DFT. The first comparable topic is the signal type. The signal is continuous time and the value is continuous valued signals. For the DTFT, the signal is discrete time signal and continuous valued signals. And for DFT, this is discrete time or discrete value time, which is finite length. Here is a finite length. And the second comparable topic is definitions. The continuous time Fourier transform of a continuous time signal x of t is a complex valued function x of f that represents the frequency content of the signal. It is defined as x of f equal to integration of minus infinity to plus infinity x of t into e to the power minus j twice by ft into dt. For the discrete time Fourier transform, the discrete time Fourier transform of a discrete time signals x of n is a complex valued function x of e to the power j omega that represents the frequency content of the discrete signal. It is defined as x of e to the power j omega equal to summation of n equal to minus infinity to plus infinity x of n into e to the power minus j omega n. For the discrete Fourier transform DFT, the discrete Fourier transform is a sampled version of DTFT. Sampled version of DTFT. That means DTFT is a continuous infinite length, but discrete Fourier transform has finite length. That's why the DTFT is a sampled version of the discrete time Fourier transform and is applied to finite length sequences. For a sequence x of n of length n, the discrete Fourier transform is defined as x of k equal to summation of n equal to 0 to n minus 1 x of n into e to the power minus j twice by small n k divided by capital N. Here the k is, the value of k is 0, 1, 2, to n minus 1. Now the topic is domain. In continuous time Fourier transform, x of f is defined over the continuous frequency variable f, and for the discrete time Fourier transform, x of e to the power j omega is defined over the continuous frequency variable omega. Variable is omega, which is typically ranges from minus pi to pi to plus pi. For the discrete Fourier transform, x of k is defined over the discrete frequency index k. For the continuous time Fourier transform, the periodicity is not applicable, but for the discrete time Fourier transform, this is a periodic with period 2 pi, time period 2 pi. The discrete Fourier transform is also periodic, and because of the finite length of the signal, it captures a discrete set of frequency components. The application of continuous time Fourier transform is used for the analyzing signals that are defined for all time, such as analog signals. For the discrete time Fourier transform, it is used for analyzing discrete time signals, such as digital signals. For the discrete Fourier transform, DFT is widely used in digital signal processing or DSP for analyzing the frequency content of digital signals. Here's the comparison between continuous time Fourier transform, discrete time Fourier transform, and discrete Fourier transform. Here's I ending my lecture. Thank you.